welcome to an example with scientific notation. So when we talk about scientific notation, let's read through this. A number in scientific notation has the form a times 10 to the n. So it's always got to be 10 because really the 10 just kind of moves the decimal point over left or right, which makes really big numbers a lot easier to see and write. Okay? But that first number a has to be in between 1 and 10. It can be 1, but it cannot be 10. Or it can be from negative 10 to negative 1, including negative 1. Alright? So it's not going to be a number that's larger than 10 or farther away from 0 than 10 or closer than 1. Alright, so if it ever happens to be that way, just move the decimal point until it's in this range right here. Okay? And n is an integer. Integers, again, are just the positive and negative whole numbers. Right? Negative 5, 100, 3, negative 72. Alright? In other words, the number is written as a number with one non-zero digit to the left of the decimal point multiplied by a power of 10. The number of digits to the right of the decimal point in a depends on the degree of precision you want to show. Alright, so here's an example. Let's read through it. Meredith is doing a report on stars and wants to estimate the total number of stars in the universe. She reads that astronomers estimate there are at least 125 billion galaxies in the universe. An encyclopedia says that the Milky Way, Earth's galaxy, is estimated to contain more than 100 billion stars. Estimate the total number of stars in the universe. Give your answer in scientific notation. Okay, so what we want to do is we want to take each galaxy and we want to multiply that by the number of stars each galaxy. Wow, there we go. Okay, we want to take the galaxy, multiply by the number of stars per galaxy, and we'll get the total number of stars in the universe. All right, so we know that there are 125 billion galaxies. We have 125 billion. Okay, and the stars, there are 100 billion stars. We have 100 billion stars, right? So if I have 125 billion galaxies times 100 billion stars, I don't know why it's not letting me do this multiply. Not letting me color this in. You see this? There we go. Okay. So 125 billion galaxies times 100 billion stars will give us the total number of stars in the universe. Alright. So I can say 1 billion is going to be the same as 1 times, well, let's write out 1 billion. So this is 1, comma, 1, 2, 3, that's 1,000, 1, 2, 3, that's million, 1, 2, 3. That's billion. So if I want to write this thing in scientific notation, I go 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1 billion is the same as 1 times 10 to the 9th. Alright? So that's how we're going to try and write some of these in scientific notation. Okay. So we can really write the first one as 125 times 10 to the 9th times 100 times 10 to the 9th. Since this is all multiplication, I'm going to write this as 125 times 100 times 10 to the 9th times 10 to the 9th. Right? All I did was just switch these two, which is okay to do. Now, can I rewrite 100 in exponential form? Sure. This is going to be 125 times 10 squared times 10 to the 9th times 10 to the 9th. All of these things have the same base, so if I add 2 plus 9 plus 9, I get 20. So I have 125 times 10 to the 20th, right? So now I can write this in scientific notation, right? It's all done, isn't it? No, it's not. Remember, that number has to be in between 1 and 10. So that means I need this number to the decimal point to be right there. Whoa, sorry about that. The decimal point needs to be right there. Since it is here, I need to move it 2 spots over, right? So I'm making this number 1.25. So I'm making this number smaller, which means I have to make this number larger to compensate for making this one smaller. So it's going to be 1.25 times, and we're just going to write it as an x, 10 to the 22nd. Remember, I moved it over 2, so it means I have to increase this by 2. So I have 1.25 times 10 to the 22nd. That would be how many stars there are in the universe as an estimate in scientific notation.